Hello, hello, hello. All right. In this video, we are going to be talking about kinematic calculations or motion calculations. So there's two sets of equations you're going to have to know to do this. The first is the velocity equation over here. V is defined as, that's what this triple line means. V, or velocity, is defined as the change in position or distance divided by the change in the time. Okay, these are the three equations we'll actually be using that are this. Okay, so V is equal to S over T, S is equal to V times T, or T is equal to S over V. These are the same equation. I'm just giving you the three different versions this time. Okay, so you should, on your notes page that you have, these three equations are there already, but they are gray. Okay, there is a ton of empty white space at the bottom of this page. Okay, rewrite these equations in red. It will help you out when you're starting to try to use them for stuff later. Okay, rewrite these equations so that they're red on your notes. Okay, pause this so you can do that. All right, I'm going to move on now. Okay, the second equation we're going to be working with is the acceleration equation. We are not going to be doing anything with that today or in this video, but I'm going to go ahead and do some quick summaries on it. Acceleration is A, velocity or speed obviously is B, V still, and T is time. That's what this is. And then these are the three acceleration equations, or the three versions of that equation that we'll be using. Not going to do anything with these, but again, this is green, the rest is blue. I would write this down somewhere at the bottom of the page so that you have a color-coded version to use. So green and blue and red. I'm going to refer to these as the blue equations for the record. So pause this, get all that done, and then I'll talk more about this stuff. All right, at this point, I'm moving on, assuming that you have done that. So we have our three velocity equations, are the main ones that we are going to be working with on today. Okay, and the variables, you just have to memorize what these are. Okay, so V is always going to be velocity or speed. Can be either because they are the same thing, except that one has direction. Okay, magnitude of the velocity is the same as the magnitude of the speed. The units are going to be the same as well. The only difference is the direction. So velocity or speed, both are going to be V. S is for distance. Yes, I know you want to use D, and you can do that on your equation if you want, but the equations I give you are going to have S. And then T is for time. Okay, now, the reason why S is distance has to do with the fact that there are 1,000 variables in physics, and S is the most convenient one for distance. Okay, again, we're not getting into why in this class, but because there's so many other variables, we use S for distance. Okay, and then acceleration, velocity, and time, we'll save those. And then the delta up here, this is nothing new because you guys have already talked about this with sound, but delta or the triangle means change in, which is always final minus initial. That's how this delta V becomes VF minus VI. So I should mention that. All right. Now, on the back side of that paper, we are going to actually talk about our velocity calculations. I need to see if I can't get this both up. Can. All right. So there are two methods that you can use to solve velocity problems. And I'm going to pause this and see if I can't make this a little easier to read. So give me a second. Okay. Hopefully that is a little easier to see. So there are two methods that we're going to use to talk about to solve this. Okay. And the reason that there are two methods is because in reality, most of the time when you're doing velocity problems, you are going to have to do unit conversions. That is one reason why we did unit conversions in the last unit, to make sure that you know how to do them. Okay, so we're going to start with the one-step method, and then we'll do the two-step method. I prefer the one-step, but I've had a lot of students prefer this one. So whichever one you want to use will work. We're going to solve a practice problem using both of them. so you can kind of see how that works, but I want to go through these first off. So first off, on your one step, you need to, and this is the same no matter which one you decide to use, you need to go through the question and identify what you have. What do I have? What am I trying to find? Label them. Literally write the letter on the word or above it or below it so that you can see it when you are trying to look back at it later. Okay, now how do you tell? How do you tell which one's which? Your units. That's why we spent so much time talking about units before we got here. Okay, your units will help you figure this out. But label your speed or velocity, your time, and your distance. Okay, all three are in the question somewhere. One of them is going to say, what is this thing? But that's still the thing you're trying to find. Okay, then you need to choose which red equation you're going to be using. So of the equations from the previous page, okay, which are v equals s over t, s equals vt, and t equals s over v. I'm looking on the board because I have them written up behind me here. Of those three equations, once you know what you're trying to find, which you figure out the first thing here, then you can figure out which equation you want. Then you need to do your conversion table. So here's the difference. In the one-step method, you are going to convert your speed or your velocity. Okay? Do that first. Okay, so you'll convert the speed or velocity so that it matches the units for your distance and your time. Okay? Then, once you've done that conversion, then you can just plug into the equation and calculate the answer. Plug and chug. Super easy from there. On the two-step method, the first two parts are the same. Identify the variables, choose your equation. Then, instead of converting the speed, you convert the distance or time, whichever one you know, so that it matches your speed or your velocity. Then you plug those into the equation, you're going to get an answer that's going to be in some time unit or distance unit that you will then have to do a second conversion for to find the answer. Now again, I'm going to work two problems here, or work the same problem both ways, so you can see both. So I'm going to pull that up, and then I'll be back. All right, so this is the practice problem that is on the notes page. So this is, if you pull up the notes on your computer, this is the practice problem that is in the notes. Okay, so practice. I drive 57.6 kilometers at 70 miles per hour. How many minutes was I on the road? So we have three things to find: speed, time, and distance. And we're going to label those with the appropriate letter. So, first thing here, I drive 57.6 kilometers. What is that? Stop. Don't worry about anything else. We have a number. If we have a number and there is a unit attached to it, we need to identify that value. So, kilometers. What is that? Is that a speed unit? Is that a time unit? Or is that a distance unit? Hopefully you said distance, because that's correct. Okay, that is our distance. So that is S, because S is distance, not D. Okay? Then we have another number, 70 miles per hour. Doesn't matter anything else. We have a number, 70 miles per hour. What are the units? Miles per hour. Is that a speed or is that a time? Well, it's speed. So that is our V, velocity or speed. And then the last thing here is how many minutes? Again, we have a unit. There's no value this time, but we do have a question, how many, and a unit, minutes. Well, minutes is time. So this is saying time has to be in minutes, and that's what we're trying to find. So I'm going to put a question mark next to the T. So we know S, we know V, we know T is what we're trying to find. So I'm going to list those over here. S equals 57.6 kilometers, and V is equal to 70 miles per hour. And then T is what we are trying to find. So now we need to figure out what equation we want. Well, we want the equation that's solved for T. So if we look at our list, we find that T is going to be equal to S over V. That's the equation we'll use to solve this. So now we just have to do our conversion. So the thing you want to convert, if you want to do the one-step method, you always convert the speed. Okay? So if we're converting the speed, we need to convert miles per hour to what? We need to make the distance unit here, miles, match the distance unit here, kilometers. And conversely, we need to make the time unit here, hours, match the time unit here, minutes. So we want to convert this from miles per hour to kilometers per minute, which is probably going to be a weird number because kilometers per minute is not something you usually talk about. So we need to convert this to km per min. So we build our conversion table. We start with the thing that we were given, 70 kilometers per hour. So that's 70 kilometers per 1 hour. And I'm going to have to write this small so that I can make everything fit. So if we are going from kilometers to miles, the first step is going to be meters. So there are 1,000 meters in 1 kilometer. Kilometer has to go on bottom. So 1 kilometer is 1,000 meters. Then our kilometers are canceled. Now we need to get from meters to centimeters. Hopefully you have your maps still. Meters to centimeters, that's going to be 100 centimeters per 1 meter. I wrote that upside down. Hang on. We need the meters to cancel, so meters has to go on bottom. 1 meter per 100 centimeters. Our meters now cancel and we're in centimeters. Then centimeters goes to inches. So 2.54 centimeters per 1 inch. Centimeters cancel. Now we're in inches. Inches goes to feet. So 12 inches per 1. Good Lord. 1 foot. Inches cancel. Now we're in feet. Last step, 5,280 feet, not inches, to 1 mile. Okay, so that does our distance. We are now in miles. Okay, but we still need to convert our time from hours to minutes. So we're going to tack that on the end here. Hours to minutes. There is 60 minutes in 1 hour. We want 1 hour to cancel. It's currently on bottom. So 1 hour has to go on the top. The 60 minutes goes on the bottom. And now we can calculate that out. I'm going to pause this and do that. All right, so you plug that into your calculator, and it all comes out to be 0.73249. So the question now becomes, how many digits? Sig figs. Well, the only number that matters there is this one, the 70. 70 is 2, so this needs to be rounded to 2, so 0.73. So V is now no longer this. It is 0.73 miles per minute. Okay, now we can plug this into our equation to calculate the thing we're looking for, T. So we take S, we divide it by V. So we plug in our S, which is the 57.6 here. So T is equal to 57.6 divided by V, which is our new number now, 0.73. Plug that into a calculator. And that gives us 78.904 minutes, or 79 minutes would be our final answer. Now, why do this weird conversion in the middle of this? It's so that we know we get an answer in the right units. Okay, by doing this conversion, we have made sure that the kilometers on this unit and the kilometers on this unit are going to cancel. And because this was in minutes, we get a time that is already in minutes. No more conversions necessary. Okay, so that comes out pretty nice for us. Okay, and we just get the answer. Using the two-step method, we'll do two conversion tables, one to convert distance and the other to convert time. I'm going to show you how to do that next, but first I have to erase all this and scroll a bit. So I'm going to pause this. Actually, I'm going to step off screen. You pause this. If you are missing anything, back up if there was something here you didn't get. And when you're done with that, move on. And I'm going to go over the second method, the two-step method, instead of the one-step. All right, time to erase. All right, so the first part of this is the same. We go through, we identify the numbers. 57.6 kilometers has to be S because kilometers. 70 miles per hour has to be V because speed, because of miles per hour, distance over time. And how many minutes means what is the time. Okay. Now, what we're going to do different this time, and we're still using the same T equals S over V. Okay. What's different this time is we are just going to convert what we have to when we have to. Okay. So, we need to use this calculation, take S and divide it by V. In order to do that, S and V units have to cancel. So the S units, the distance units, and the distance component of the velocity have to cancel out. Okay, so instead of converting this, we're going to convert this. 57.6 kilometers, we're going to convert that to just miles. So we start with 57.6 kilometers. And now we're going to convert that to miles. Okay? Okay, so we're going to go through the same process. Sorry, I had to check something. Now, so we're going to go from kilometers to miles. So first step is to go to meters. So that's 1 kilometer per 1,000, not 100, meters. Then from meters to centimeters, so that's 1 meter is 100 centimeters. Centimeters to inches is going to be 2.54 centimeters to 1 inch. And then 12 inches to 1 foot. And 5,280 feet to 1 mile. Plug that into the calculator. And after applying sig fig rules, we get that 57.6 kilometers is equal to 35.8 miles. Okay, so this is S. Now, the distance component for our S and our V are the same, so we can plug into this equation. So T is equal to S over V, or 35.8 divided by 70, which is going to give us 0.5114, or after sig figs, that would become just 5.1. So 0.51. But what unit do we have? It's not minutes. We are in hours, because that's the time unit that was part of our velocity. It was still in hours. So when we do this conversion, or when we do this calculation, we have 0.5 hours. That is not the answer we're looking for. We want minutes. So now we take this number, do another conversion table real quick, and convert that from hours to minutes. So there are 60 minutes in 1 hour. So we just need to multiply by 60 to get our final answer. 0.51 times 60 will give us 30.6 minutes. And that is going to be our answer. Okay? Now, what I paused for a little earlier, some of you might notice this is not the same answer that we got on the first part. That is because I made a mistake. And you probably noticed this, I accidentally put kilometers on the velocity in the first one, so I did the first one wrong. The process is the same. I just wrote my units down wrong, which means my conversion table is backwards, so I got the wrong answer. I apologize for that. So those of you who are watching this video because you were not here, I apologize. Try to make sure I don't make that mistake in the future. But I don't want to re-record this almost half-hour video. I, again, apologize, but that is pretty much it. Now, there is a worksheet that has 8 practice problems. You can do whichever method, the 1-step or the 2-step, you can do whichever method you prefer. Both will work as long as you use the right units. Both will give you the correct answer. Okay? So use whichever, work through those. I should have a key available. I don't know if it's digital or paper, but there will be a key available so you can check your work as you go. And that is it. So, again, I apologize. I made that mistake. And I'm going to go ahead and move on. So have a wonderful whatever, day, night, evening, morning, whatever. And I will see you next time.